Hello, what's going on? This is Chan, and we are back for some Purescript. So let's just get into it. All right, so what did we have? We had none of that. What was it? Ah, that was it. We had beginning of something that seemed to be actually submitting to a chronofold after some initial loading, I think. Yeah, there we go. So we have our log actually displaying our chronofold here, and we can backspace and also space. So that's nice. So now what we want to do is hook up the, the networking. So one of the question is, how do we do side effects within Purescript React Explorer? So let's see. Script React Explorer side effects. How about that? Effect monad. Da, da, da. Yeah. So maybe Purescript comonadic UIs. How about that? UI side effects. We've set in order to support side effects. Okay, let's look at how exactly does it. Although we know that we didn't buy into all of the changes that Arthur did. But okay, so we have a base monad for side effecting purpose, right, which is basically um, which I think is for in Purescript React Explorer is effects. So we might want to change that to F. We might want to parameterize this as base. But I think this basically allows side effect. What it doesn't do is allow, or it's not clear whether it does or not, is allow side effects where the interpreter is effectful. So that's the little bit of the tricky part. So to figure this out, we need to look at co-free interpreters and side effects. No, not we don't need co-free. So that's one of the blog posts I remember we looked at. Effects. Try to add some effects in the mix by using free T. Adder monad. Hmm. Well, by adding an M here, I'm not sure. You can generalize this to work with other effects. Adder T, free T, adder F, MA, and then clear total. Relationship M as identity, the two are equivalent. So building a monad transformer stack, apparently, and basically, so dealing with composition of co-interpreters through a stack, a monad transformer stack approach. I don't know if that's what we want. Also, I haven't. So let's write these things down. Commodity QI. Okay. So this here. Lessons in commodic UIs. Right, effects. Inco interpreters, like here, right in this post. Adder T has a monad transformer shape. So that's one way. So then it means that M could potentially be effect. which I suppose is not unlike adding effect here, except it's yeah, it would be more something like cofree tm and kernel fault space m, and then being able to pass effects as this m, and then also stack multiple things. But then the question is, how does Purescript React Explorer compose cofree DSLs? That I am not completely clear about. I'm wondering whether this would be actually with the day convolution and sums and lists. So let's see. So sum of two comonads allows to be in one state or the other at a time, remembering the other state. You also move from one state to the other using the move left and move right actions. So that's like tabs, basically. And that's one form of composition. And so let's, so we have sum, like or tabs, switching between components. So since coactions, or since components are parameterized with a comonad, the comonad determines the component, and so we're kind of saying that the sum of two vocabularies becomes the or the either of two vocabularies becomes the either of two components. So that is more about, shall we say that this is more about some form of horizontal composition, which is somewhat laying out components in some sense, right? Whereas here we're talking about capability composition, really, right? Capability also a little bit in the kind of three-layer cake way. And I was reading this Thomas Honeyman halogen tutorial. I don't think that was pure effect to the edges, where yeah, I think capabilities, yeah, implementing a logging capability. So all of this are good design patterns that we probably want to include. And here capabilities are, yeah, I think they're expressed through type classes, basically. So, right, and then there's some convenience to be able to call the effects directly from the monadic actions. In our case, it would be comonadic actions, I suppose. So there's some form of maybe composition of co-capability. I'm not sure what that's going to look like, but here our counter has, for instance, change and ink. And so these define monadic values because they're co, right? And a parameterized monadic value here. Could we extract type classes from that? Maybe. In which case, I suppose that would give us some modularity in regard to how we compose capabilities indeed. So that seems like, yeah, that a stack transformer would be to add several capabilities, right? Like backend capabilities, like state and logging and you know, network and such, right? So that's kind of what we're looking at right now. Rather than this more horizontal composition. And because the horizontal composition is going to be between components that all basically have all the capabilities or the whole monad transformer stack. So I suppose the easiest would be to start with the monad transformer stack or co-free T transformer, which I think is basically, yeah, that's basically what's done here. And I think that's also what's done in Arthur Xavier's case, where I think we have co-free T. No, we don't have co-free T. I thought we did. Okay. Um, let's see this co-free T here. Not the typo. There isn't. Oh, I'm looking at the user. That's strange. T in this repo, it's not there. Okay, comonadic to do and friends, comonadic to do's. Isn't there coffee tea here? There is coffee tea here. And is it used for what I'm thinking? App space, coffee tea app interpreter. More tea. Oh boy. I shouldn't go into this, but I want to look here because this is pretty interesting. Yeah, Moti is implemented in terms of coffee tea. This machinery is super interesting to me. I'm not sure why. No, I mean I know why because I think more is the sort of the clock ticking of the free matching, where the free gives a direction, the co-free is a position in space, and each tick of this is actually a kind of a an event-driven tick or a clock-driven tick, and that more t or more actually represents a machine that ticks that way and can be the one that assembles. Basically, I think it's to say something like maybe explore or maybe build co-free or explore might be expressible in terms of co-free. More T, maybe. Let's see if that's something that is even looked at here. So UI React Explorer and explore sends and base and writes a move, and move is from control command pairing, and well, uses the pair and the duplication. Yeah, I remember we were a little bit confused here. I wonder whether this can be reduced somehow to more. And actually, I wonder whether yeah, I think I remember making a note about this whole malarkey. Not in here visibly. So maybe I'll write here. So intuition that more is the time ticking component of time ticking aspect or stream advancing aspects that can power a free co-free pair. And I think the reason why I'm interested in that is that this might be an adapter interface between the free, co-free DSL world of Common-Adic UI and the perfunctor coroutines of Purescript run streaming. And therefore maybe also the FRP. Ara is the FRP world. Yeah, I seem to be a little bit obsessed by the idea that maybe underneath this component structure, I can have a lower layer that is more expressed in terms of streams and FRP streams. So maybe I should write this down. The vision here would be that get some water and check out the chat just in case. Didn't have a lot of people. Oh, Joe Christian is streaming at the same time. That has been happening. And dashboard, stream manager. Okay. Would be that upper UI layers would be expressed in co-interpreter DSLs with Common-Adic composition, some list day and layout, various layout, while middle layers would provide capabilities and lower layers, or maybe it's still middle layers, would be wiring components, or I suppose middleware as with streaming abstractions. I think that's what I mean here. I think it's still not obvious whether, let's say we had, and let's say we have a calendar and that it has a timeline in it. And the timeline has events. And maybe it also has like some scales, right? Then we might want to stream to events. Let's call this an example. If the component tree structure is like so, Um, then maybe the event component subscribes to a data source. Um, and I suppose here there might be a view port, something maybe, and to to a data source and to the viewport component state, zoom level, uh, focused segment, right? So we're laying out components, and then we want to somehow say something like, we want to say like the UI is something like, calendar and off timeline of events and scales. So I want to try and declaratively say that, but then we want to say something like data is, and here we have like a viewport. I want to say something like events somehow feeding into, or maybe, viewport. Um, what do we want to say? We want to say something like, the viewports zoom and segment together with the like a data source, right? So source of like database equals something, right? Like some what was I looking at earlier? I was looking at dgraph, I think. Is it dgraph that had okay, let me open what I was looking at just earlier. Yeah, TypeDB. That seemed to have a gremlin interface. Is it right? No. So, right, it's DataStack graph engine that has a gremlin interface. And I'm not sure how you get that. How do you install DSC? It's just DSC, right? DSC graph. Yeah. So, okay, fine. DSC graph, for instance, we say. And then maybe, query equals whatever, right? It's equal g dot some vertex plus whatever, some gremlin there. And then we pass that to events, probably through some transform, right? Like, but maybe actually it's nice and there's no impedance mismatch, and we actually pass those things just neatly to events. So in this case, we're sort of saying that we're saying a couple of things. Either viewport as a component, as a commonality component that can be laid out inside a layout tree structure like so, has data wiring that is also connected to components themselves, including some utility components. Which might, by the way, mean that we might want to connect this to some sink, which might be the DB again. So if we do that, then maybe we want that the driver, maybe the driver representation is quite elegant. Since obviously we also want to capture, for instance, like people clicking on scales, and then that would impact the viewport, right? So how do we want to model those as, let's say here, having the view, saying that somehow we pass through viewport events? I mean, it sounds like actually building an overall graph like that is not really the solution. What we want is do maybe more pointwise, okay, maybe building an overall data component graph is not so straightforward. Maybe we want some kind of pointwise subscription. And that might be actually something like decorated code spans in these guys, where we say something like, yeah, viewport zoom impacts the source query actually, and maybe like maybe the query and maybe like some like optimistic fetch cache or something, right? Where we want to say like zoom times 3 or whatever, like I think I want to say segment here and then segment times 3 here or something, which means that we're fetching, or times 5, we're fetching the current segment and then 2 segments before and 2 segments after or something like that. Fetching 2 segments before the current segment and the next segment and the 2 next segments. Similarly, we could say viewport dot zoom also impacts some optimistic fetch cache. That would be, I don't know, and that would be something like LOD, no? And so maybe it would also be, we can, is that as is lambdas? Makes me think of the parametric higher order abstract syntax thingy for structured graphs, where I think lambdas are used to specify edges. Because of course we want to basically take this parameter and use it somewhere there, right? Like, which is exactly what we do here. We say segment times 5. Obviously, query is going to be impacted by that. It's going to be something like, yeah, segment. Or maybe that's just segment times 5, and we don't care so much right now. We don't know what the query language is going to be like. It might be gremlin, might be something else. And so we say query, and there's going to be some zoom in here, but we don't know how, for level of detail. And then we do something like, so if you want to say that the click in the scales sort of can, for instance, translate the segment, then we say um, scales dot on click or something, right? That would go to viewport segment. Maybe we'll get x and then equals segment plus x. We translate the segment. On scale click, right? Something like that. Um, and then what else? Like we were saying, yeah, clearly, right. So here, in truth, what we have is, in some sense, UI here, right? Which contains events somehow. And we want to route things inside events. But see, it's pretty tough to try and represent the whole graph like that. So whereas if we say something like, yeah, something like source dot, um, well, that's the output of the source. So source dot data or results goes to maybe, yeah, maybe it's just source dot results. And then we say UI what do we say? Do we want, I mean, if maybe we just pass it to event then. Events. And that's it. We make it so that we just load the results rows into the event component, which expects them. And so in fact, yeah, when we're saying that Zoom impacts the source, we are saying something about a cache as well, which is slightly different than what we're saying about engaging with the source. So I may be calling these sources is wrong here. We call it state. And then sync, how would that work? It would work in the way that event dot some DSL, like modify, or let's say remove, that would go, well, actually it would be a DSL, right? So it'd be like the CRUD DSL or something. That would go to state.crud or something, and that would be done, right? Because that should be a standard way to interface add, remove, edit, update, blah, and have the equivalent thing here. Just CRUD. So now we'll be basically saying that things that happens inside the component event that belong to this CRUD DSL somehow are just or interface, whatever this is. It could be, I don't know, a type class, a standard co-interpreter definition, or I'm not sure. Probably a type class, maybe. I don't know because it's not clear how we're going to do type classes and how we're going to do capability composition in with this model. It's really not do not know, but that kind of makes sense, right? Just CRUD. So component add well, component CRUD generates what's expected. So it's a little bit like implementing an interface, right? Component implements CRUD interface and generate what's expected by state capability. So now we try to somehow we maybe encapsulated things, encapsulated the connection of events to states, and then we also we don't yeah we also have the backward transition, the state to event. So maybe that's again CRUD, in fact, something, right? And maybe that's here we're kind of tying the knots, and we're creating. I mean, this is obviously a bidirectional, yeah. So state bidirectional link. So that means we tie the knot somehow. Tying the knot means we know we have a circular reference here, but we know how to jumpstart. We know how to initiate it, which is we initiate it in a more machine way, I think. A different thing, more here, yeah. Meaning I think a more machine expects a starting state. And so that's probably just the initial query. So that would be with an initial input, which could be the initial query results. Because usually when we open something, we'll have a default query, and then that's enough to start up. And then we pass that to the event component, and now we're holding until we receive the next tick. So the knot is local. Ticks relate to what to the interactive semantics of the events component. In this case, it's a UI component, so we pause waiting for user interaction. But it could be something different, right? It could have a semantic way. It continues ticking. As long as it just doesn't create a feedback loop that goes, that is not managed by some actual intentional clock, and that just instead blows up the stack because it's calling itself recursively, then we have a problem. But since I have no idea how I'm going to implement this right now. I'm just dreaming some DSL, right? So I'm dreaming some DSL in which, well, in fact, if it was, if we wrote this in the host language, I mean, basically what I'd like is this to, maybe, okay, how to implement this. Let's ask ourselves this a little bit. If we use actual functions in the host language, then this could be some kind of ISO, maybe. If we have a DSL, well, if we use data to model some kind of computational graph, then what? Then we have to build a lot of machinery. Basically, interpreter, compiler, and all this stuff, which we already started kind of looking at, right? In another stream when we're trying to model graphs. Specifically, the streaming, where we look at using free arrows. And yeah, one of the ideas was to piggyback on the arrow notation to maybe construct graphs. But we're also looking at this parametric higher order abstract syntax there. I think because it was very elegant, but also that would be a lot of machinery, but it's also not incremental. And we were also looking at whether we could make this incremental. But this is all very hard. It's all very hard. Oh, have I been writing this in my old log? It's not the best. We are July 1st, so let's create a new log entry for that. And just copy this here and then undo. I think that's the whole thing. Boom. Okay. Yeah, that's my other attempt of trying to understand how these two things might live together. In typical Junchan fashion, I write a lot, but I don't reread myself much. I think it's because I'm somehow expecting the things that matter to stick. And that might be the wrong assumption, but okay, so yeah, we'd have to build a lot of machinery if we are to build a computational graph. But obviously, if we do build a computational graph, then we have introspection and like we can reuse all of our graph machinery to almost build an IDE, right? So we know we want to get there. Is there an intermediary state? I think there's probably some intermediary state. but it depends a bit how to implement this. We need to play more with capabilities in a comonadic context and see if we can actually plug in something like something something data flow like underneath. And to be honest, if I look at this, I'm also now thinking a bit about ECS. Like the viewport component, we get the zoom property of it, we query it in a system, or actually, yeah, in a system, we make sure that we update. This could be a system, this could be a system, or this could be a bigger system. We query components and properties. This is really an entity, actually, I think, sort of. But events, that might be a bunch, a class of class of entities, maybe. Huh. I think that it basically is this decoupling of the data and the kind of a streaming. I mean, a streaming is not quite right to think that way. A subscription, an event-driven good subscription model there. Maybe that would, maybe that's relevant here. And then it's the, so all of the kind of, how would you say, the effectful and behavioral aspects are really straightforward to write, but then then possibly the UI composition layer becomes a little bit more tricky. I think that's not necessarily true, because it could just mean that we do something like UI what am I saying here? We're wiring, right, we're wiring all these guys like so. Like so. And maybe we call this UI, and this would be all of the inputs. Is that right? So we query anything that's called calendar, and that's kind of some entity. So, or even like we can say it's a component. Maybe there's only one component calendar, but it doesn't have to be. Maybe there's one or several timeline components, entities, but we fetch them all, or we just fetch one. Maybe it's a singleton global entity, and then we say that's how we display them. And maybe it kind of means UI here, that we're actually looking specifically at the UI side of things. Yeah, maybe maybe that is what we do. So that becomes the rendering. It becomes the layouting, which is different from then what would drive maybe the content of these things. So layout is like so. So everything is very decomposed, and I really like that. And that feels really like ECS, this kind of like very neat decoupling. Um, but so that doesn't fit at all what we have currently, except maybe, I mean, okay, let's compare. Okay, let's write this down. That doesn't seem to fit at all what we have currently. Uh, um, overall building the overall data component graph is not straightforward. That's clear. Can't really imagine myself doing that. The okay, the components. Okay, maybe we could see if we squint. Could we see this as a system? No, that doesn't quite work, does it? That's an entity. Change counts are sort of interfaces, so that do feel that does feel like a system, right? And so the interpreter, I think the fact that this is a singleton entity with only one component, that's I think okay. Let's try this to reinterpret this in ECS. Maybe counter model is a singleton entity. Count the component, then counter interpreter is the API for a system, and interpreter itself is a system. However, if we look at the rendering of the UI here, it does assemble a bunch of stuff. And we do get send, and from send we do get to use whatever DSL we want to use. Those are still abstract. They only get concrete here. It's only the API that we use here. There's no such thing as kind of component selection and querying, but we probably want that, especially if we had some kind of data entity or like a way to load, load state as entities or something like that. The question is, are we as granular? First of all, can we say something like that? It seems like probably yes, we can actually do the vertical or horizontal composition of components and child components, actually maybe also using sum and day and list, I suppose. It's not clear how we nest, I gotta say. Oh, well, I suppose list is a form of nesting. And maybe day is also, day is two things side by side. I don't think it's nesting, but list is nesting. And list, list is nesting, but with, I mean, we'll want that, but I wonder whether there's a more static, it's a dynamic nesting. Is there a more static nesting? So that's a good question to wonder about. Is there static nesting equivalent to lists, which dynamically nests in Purescript Connect Explorer? It's not clear. Some combine. Those are tabs. Let's explore some. Yeah, I'm not sure how you do basic nesting, but I think we could derive it from list, but it's not easy because list is pretty hard to understand. It's recursive. This is pretty neat. Yeah, it's more than neat. It's really amazing. Explains some construction. Maybe we need to look into how day works. So the way I understand day is some kind of product of comonads. Something where we have this kind of combinatorial explosion of all possible states from X and Y. And I suppose nesting feels like that. Does it though? Yeah, no, it does. Oh. Yeah, this is hard. It is pretty hard. Okay, I'll take a tiny break and I'll be back for just a bit more. Okay, just a tiny bit more. Haven't written a lot of code here, but yeah, so nesting, we just want to try nesting. Shall we just try nesting? Okay, let's do a new series of to-dos based on some of the old to-dos. But also some new ones. How to nest components using day. Then I do think I have some kind of answer about composing capabilities, which is that the monad transformer way seems to be the way, which really makes sense because that's generally how it's done, right? And so we could refine that in the way that things are refined um, elsewhere, right? So by maybe doing sort of like transformers move, like a kind of classy approach, right? Then I building constraints with constraints, really. Really type classes, basically. Um, and then is that possible to do with comonads? And so do we want to start just by indeed just making by using cofree T M and then just asking of kernel coaction or oh, well, that's interesting, right? Oh yeah, we're saying that chronofold space. Oh, yeah, I'm not sure how that's going to work because right now the type of interpreter is linked to the type of chronofold coaction. Um, and to be honest, I really don't like this type, the tuple type there. I'd really like to change that. I think it's a bit hard to understand. And I think it comes from this tuple here. We're trying to return a tuple because step editor is then passed to build cofree that wants a tuple. It could be that we just decouple those two things. The problem being, of course, that if we decouple those two things, then, for instance, we won't be able to factor log out. Since we use log in both places. Okay, so maybe the tuple is not a problem. And maybe we use nested tuples just to make things pretty. And this. And you know what? Would that actually allow us to get rid of the parentheses? Because that would be a big win in my book. Yes, it does, yeah. We don't know what cofree T is, but that's fine. I suppose, are we importing that? Spago. We import, we don't even import free. why, and how come? Is is free? Oh, we have free co-free here. Oh, but we don't import that. Right, so we have some version of co-free here, but visibly we're not using that. Okay, I'm a little bit confused now. What are we using? Control command at co-free. That comes for Purescript free. So I would have expected to see free here, but it's not. So maybe it's a transitive dependency. Probably is. Okay, so let's add free and I suppose free T. And let's go to the kernel file and let's paggo install, and they're already there. And so we can paggo build. Will that give us free T? It won't, because we need to. Oh, okay, too many open files. That's probably because of this guy. Plus, yeah, this is also compiling, I suppose. But there we go, it's working here. And I suppose we are now wanting co-free T. So co-free T comes from free T, and it comes from control command co-free trans, which we had there, but I think for now we import the whole thing. And even though it might be in the same implementation, at this point we try and use the canned one, and that should resolve go-free T, but apparently not quite yet. Fail to build. I save again. Should I restart the IDE? Is it with a capital F? It's not. And co-free trans. So fine. Let's import co-free T manually. And you're saying it's not there. The module doesn't. Ah, right. Okay. Yeah, because you still think there's a module here. But that's not good. You can't think that. So we need to correct you. And maybe it's by the build. So now co-free trans is not found. So let's see whether we actually have free T. We do have free T. It's version 5. Supposed to have this, but I suppose maybe we need to reset the cache now. So let's remove the output and build. Let's remove the whole Spago thing and build. And Spago down and free T. Not some. For some. I'm a little bit tempted to just remove that whole thing, but output control command code free trans 2. Did you import free T? Say that you copied it from the global cache. And it seemed to have control Control monad trans free trans in it. Oh, hold on. That doesn't have comonad. Control comonad co-free trans. Only monad free trans. Hey. Okay, so that explains it. And therefore we shall, what shall we do? We should probably point to free t in its latest version right here. T and dependencies are this. And don't you wish I knew how to use my editor? Oh, that makes for very compelling content, doesn't it? At some point, I will be ashamed enough that I will learn. And here, just go pretty blah. .git. And version will be 6.0.0, I believe. But let's double check. Tags can be a nasty thing, and probably V. And downloads, and I believe we have control comonad. Coffee is not there yet. Coffee trends. All right, we are all good. I mean, of course, there's some type error, but we made progress, right? So this, in theory, should now build. It does, and now we have some type issue, and that makes absolutely sense. Right. So indeed, the other thing that was happening in here is that the base monad was passed there all the way down here. And then it was a component T where you could actually also specify an M monad right there. Um, but yeah, I'm not sure whether I want to do that. Yet, at least. I think we want to try from a kind of vanilla handmade transformer stack first. And yeah, just to clarify here, we want, so if we say that we want effect, then we're saying that what are we saying? Saying that. And then here we're saying also the same thing. And then here, aha, yeah, here, that's good. That is kind of what we want. I wasn't expecting that it would just work, but it sounds like indeed we'd want to be able to just, hold on. No, actually, that's wrong. Yeah, that type check. So no, that's not correct, I think. Oh, 1 second. Just the wind. Right. So wrap free now would not have the correct type. No, it's not wrap free. It's is it send? Right. This adds complexity into a place that is already pretty difficult to understand. I mean, I still have all the types, but clearly here instead of co-free chronofold coaction, we have now co-free T effect chronofold coaction. So um, that's not easy. But I think maybe we can do it. So let's try. So this is now co-free T effect. So that means that wrap free is co-free T effect here and co-free T effect here. And then it means that yeah, given that append oplog is co-chronofold coaction, then here pure unit was what? Was any T of unit, but T would just be put to be co-free, blah, all of that stuff. And why wouldn't that work anymore? Is it because append yeah, it should be okay with being co-chronofold correction again, I think. But maybe it's not the case. Let's check the more polymorphic type of wrap free here. And we're saying F, which is this M, oh yeah, FMA to MA. Yeah, no, that's all good. So maybe it's just pure of pure unit. Could that be it? No. So maybe we try and ask, what should it be? Well, A has input type T0, so we don't really know. Okay, what about this guy? I mean, is it because of the type of append? No, because we established that this shouldn't matter. Oh, hold on. I say it shouldn't matter. But yeah, no, it shouldn't matter. Just want to discard M and then, so it is about that pure unit there. It's that pure unit. We want it to be a, so let's try this. Let's try this. And I'm expecting this should be co-free T effect chronofold action unit. Apparently it's not able to do the type inference here. not able to do it. Hmm. So I suppose the question is, how do I build a value of this type? So it seemed that for some reason, building a value of that type was more straightforward for an unknown reason. For some reason, I mean, somehow that pure unit was of the correct type. So that's a bit baffling to me. So baffle would be of type this, and then you're saying that pure unit is a valid baffle value. But you're saying now that baffled or baffles, if it's now Cofree of effect, then you're like, no, hold on, like, that's not there. Oh, okay. Oh, it's because there's no type class. Oh, common for correction. Oh, yes. I think it's because we need to now add the pairing of the Cofree, and I think we have that somewhere. Uh, yeah, here, but it's not in the right formulation, I think. What we want is something like this. Free T pairs with Cofree T. And free T, I suppose, is it of the same monad or a different monad? Hmm. Hmm. I think it's probably a different age to pair. Is that? Well, let's look. Should be there, right? Blah, 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 pairing. Yeah, F and G and FG need to pair. Yeah, yeah. Here the M and W, and so it's not the same way. Oh, hold on. FM. Okay, I'm a bit confused by the order of parameters here. Dun, dun, dun. Free T, go free T, F, W. Okay, let's look at free. F, frequent transform to factor F. Oh, okay. Oh, okay. So yeah, no, FM then makes sense, and then GW, and then we want not only let me check. Yeah, pairing MW as well. So we need also to get but then do we break the I think then we break the interface, don't we? Because we need two pairings. Is that one of the reasons why you have to go type classes? Pair free, co-free, indeed looks fairly simple. Here you're passing M and W. Yeah, damn, that sounds complicated. But let's try it like so. Let's try it as if it was just going to work. MW, and then we have the other pairing. F, and then what? Why are we passing M and W here? How come all of a sudden pair has an arity of 3 there? I mean, I suppose, oh, okay. Yeah, maybe it did have an arity of 3 already. Okay. And here too, yeah, okay. All right, so other pairing and then M and W. And yeah, I have no idea how to implement that. I mean, I suppose this looks very close to this. Explore zap pairing instead of explore zap, because zap takes pairing. And then I suppose we probably need to then pair M and W in a tuple. I'm not sure why. Just the functor tuple. Is that just a pattern match with the result? Product. Do we want product? Is there a difference here? It's using here. There we had tuple. We had an instance for tuple. Oh boy. Okay. So I think we need an instance for tuple. It needs to be what? Tuple and function. Really, we don't have tuple and function here. That's we don't. Okay. So tuple function for FG. Oh, that's okay. Text to pairing there. So FG and tuple A and is that how it works, right? Oh, yeah. I think tuple A and function from A. And then tuple function as a pairing. And F a product tuple. AB probably. And a G. And it's an FBGA. Without the pairing? F is the no. Yeah, without the pairing apparently. Oh, because there's no F and G's here. This is just a flat pairing. Boom. So there you go, Bob's your uncle. So now enable, okay, yeah, tuple AB. So now in theory we have an instance for the pairing of tuples, which should allow us to then, we need to import free T and co-free T as well. Control command add co-free trans, co-free P, and control monad, free trans, and free T. Happy now? Nope. Yes, because trans needs to be spelled correctly. Yeah. Okay, and now what? Now type variable A is undefined. Yeah, sure. All right. That's legit. Type variable M is undefined. Okay, yeah, it's true. MW. And then we don't have the right type, but that's hopefully okay if we copy that thing. and try to judiciously add pairings. So this would be other pairing, would be P2. How about that? P1 and P2. And this would be P1, I believe. And then we're done. No, we're not. Unknown value step. Okay, class step. Step is from this particular implementation of free, isn't it? Okay, I mean of co-free. I think there's a step here. No, oh no. Okay, so I don't know where a step is coming from. Oh, step is a function that I forgot to add. Yeah, and but resume and co-resume, those do come from co-free, yeah, from here, and then this guy comes from this guy, yeah. Then either and tuple now, okay. We'll take a tuple and step indeed returns a tuple. It's going to resume A and B, which are M and W, which are a free TFM and a co-free TGW. And yeah, where does this either come from? I feel like it's coming from co-free trends. Does this have a user inside? There's not, it has a tuple. And how about free T? Does that have an either in it? It does have an either in it. Yes. So maybe that's what's going on here. This pairing used which free T? From returns. So yeah, no, in theory it should work. Pair tuple here. Maybe it's just P2 here. No. P1 should be about functor FNG. Functor FNG don't really appear in the parameters here. They're just implicit in the M and W. So we want to know that FNG pair, but maybe we only need the one pairing. Let's try it with only one pairing. Let's try it with only one pairing. No, same problem. Yeah, either and tuple. So step. Okay, let me read this again. Zap pairing provides a pairing of blah. Sim pairing of GAFB, pairing of prepaf FB, GA. FAB is FAB. Identity functor pairing with itself. Right, so it means if I have two values wrapped in an identity functor and I'm trying to pair them, I just with a function f that has two parameters, then I just pair them and I'm done. Meaning identity, bowtie identity really means that given a function that takes two arguments and two functorial thing and return the result. So here in given a function that given the pairing for micromonads, I suppose if I do that, then I need to change this type as well. I'm a bit unsure about. I mean, this had two pairings, and this seemed to work fine. Product co-products. Okay, let's. It seems like we need to have two pairings. I don't think there's a way around that. So let's say those two are P2s. Then F is the thing that we're trying to apply to an M and a W. So we'll go and we'll receive this tuple of an F and a W, and then we'll apply the pair to those things such that if we have a left, which is the either of, so that's the free T side of things, and a tuple with a B there, then we just FAB. But we still have an F and a G to deal with. So I would say maybe here we pair with P1 FAB. I think that makes sense. And then if we have a right and a tuple with some tail, then we go again because we need to recurse in the tail apparently. So we take the right and we recurse in the tail, applying P2. Oh, actually we need to apply. Let's think here. Step is a two-parameter function. Let's try and make sure its type is what we want. I think it's what we want. It's what we want, but maybe we want to pass it. Okay, maybe we just step and that's it. Keep the P2. No. Infinite type. Okay, so that's a new thing. Okay, let's not do P1. Let's see how that works. Infinite type again. Okay, let's look at class. Here we did use pair, so we probably need to use pair. And mouse type file false. And then try P1 here. Doesn't work. Could not match type either with tuple. So are you saying, I'm not sure what you're saying here. Trying to match type either T1 with tuple B2. Okay, let's back a build here. Trying to match either T1 with tuple B2. So clearly there's some mismatch, but what is it? When we resume, we get an either. When we, oh, hold on, shouldn't that be co-resume? What? Yeah, oh boy, that has been, I replaced with resume instead of using co-resume, that's what happened. Oh boy, co-resume, I mean, doesn't exist. Aha. So that's the thing. So let's go here and type co-resume, and we don't have it. So what's the type of co-resume in here? Co-resume is supposed to be taken from this coffee trends, which maybe is here. Yes. So what's the type of this thing? And shall we go back to the docs, coffee trends? We have head, but what do we look like? It's Kofi LW with W of a tuple and stuff. Ah, there we go. That's run Kofi T, I think. For FWA, it doesn't have the common add constraint, but I suppose maybe that's fine. Kofi FWA, 2W tuple A, F of Kofi T FWA. Yes, so this is run Kofi T. Okay, is it just going to work? Ah. Boom. Oh, we're close. Gonna match F2 with M0. Okay, so do we finally apply P1 here? No. Okay. So, in fact, we might need to have type of step, which I would expect to be free FFM to co-free TGW to tuple of the above. Is that right? Okay, so fine, we will have some carrier type. And then we do have a type mismatch. So maybe resume is not what we want. Resume. I mean, we're assuming that it's, where is it coming from? It's coming from FreeT. We don't know which version. Could it be that there used to be a resume in here? Resume. There was, or there is. Impacts FreeT. Takes a FreeT FMA. I mean, I think this is what we're using, right? Resume for FMA, function F, mod reg M, FreeT FMA, either AF, FreeT, yeah. Oh, right, yes. So it's not a tuple FreeT FMA, of course, because it takes the FreeT FMA, but it returns this M either blah. Right, so it's much more complicated than that. So it's this, and it's one go free T, one go free T here, W tuple blah. Okay, what do we have now? So some mismatch. So we want FMA and GWA. And here we obviously need G's and G's, and that should be it. And yeah, it seems like it passes. Now it says something different about F and M. Okay, let's try and build that. it's a bit of a tough one, that one. If we apply f to AB, where does AB come up from here? So left of what? Left of is an A. So maybe it's just FAB actually, right? I think that might make more sense. But still same type error. It's rebuild. Okay. Could not match type F1 with M2. We're trying to match free F1 free T, F1 and 2 T3. Type M2 free T. Okay. So double M, either A, F free T, FMA, and W double A, G go free GWA. FM, GW. So right of FF would have an F with TFMA in it. Ah, yes. Hold on. If this has an F free TFMA in it, so let's try and type that thing. I think this guy is an F. FMA, I think. Oh, maybe. Tavero A is only 5. Okay, yeah, maybe 4A. And then step of FF. What's the problem with that? Yeah, that's where it would not match. Okay. Yeah, that's good. That's progress, because indeed we'd want to P2, hold on, P1, what, identity, FF and tel, or maybe we want to P2 after P1. Or the other way around. No. No. Yeah, because if FF is wrapped in the functor F, tel is clearly going to be wrapped in the functor G, right? And then we're going to be, oh, yeah, actually, that's more like so. And okay, let's see whether this is the way. No. And it could be that it's P1 and then P2. Is that even a thing? Not sure. Okay, what's type of P1? It's supposed to pair F and G. So maybe we just do it pointwise. So we do first P1. Oh, hold on. Is that? No, it doesn't compile. But A1 with A2. Okay. That might just be because of the type annotations now that are confusing things. So let's remove them. And let's remove the A because those are two for A in here, and that's not good. I don't think we want that. But that's not the problem, apparently. And now A1 with B2. But that could still be because of that type annotation. So let's remove it. And oh, monad rec for M3. Actually, wasn't that part of the type class there? Yes, monad rec for M. And that's it, actually. Wow, strange. Um, so I suppose we can just put it here, right? And what's the dealio? Non-type class? Okay, well, that's important. Put on a rec. Boom. No type class was found. Hey, okay, we're getting a step closer, I think. I mean, I think we've got the pairing implemented now. It's just that apparently that didn't help our cause. But apparently that we want that. Oh, common add. Okay, maybe we just need to add the common add constraint because there's a common add W constraint right there. So let's do that. Common add W and to import common add, I suppose. And still not. Okay. So you want a common add. Oh, I think I reversed it. Oh, and now we want a common add for effect. So maybe that's not. So hold on. Shouldn't we have a common add for? No, I think it's Chronophort space that has a common add, isn't it? So what am I doing here with the pair? Cofree GW. Oh, so does this mean this needs to be a co-effect? Maybe because effect might be a monad rec. But on the co-free side of things, we need the comonads, so we can't use effects, of course. We need comonadic transformers. Okay, so that's what we'll pick up with next time. So basically, this question is how do we do side effects? Before we even how do we do side effects? And we're exploring various things, but we're exploring the co-free T would require a comonad transformer stack. So is there a co-effect? And let's just search for it. Just so I think I've seen this before, but I don't know if it's something that's used as a pointer. Yeah, there doesn't exist in Purescript. So Purescript co-effect. Effect. No, I didn't mean co-effect. Ah, smash. It's for co-effects. The convolution command, of course. So that's where we'll pick up next time. And thanks a lot for watching. I'm Junchan, and this was me in a very dark room. I didn't realize how dark this was. But yeah, we see each other on Saturday. So take care and bye-bye.